Hey everyone, this is Greg Arnett from CloudTruth. I want to give you a quick overview of what we're working on. CloudTruth was founded by former SaaS CTO and DevOps leaders. We're building the tool that we always wanted our team to have access to as it relates to configuration sprawl. CloudTruth helps you manage config, which equals secrets, parameters, environment variables, across all your teams that need to interact with the data, across all your environments, and all the projects that you're deploying to those environments. We see a lot of homebrew tools. We've built many ourselves, and we designed CloudTruth to be this universal configuration sync system. It has the ability to fetch all parameter data, config, secrets, environment variables from all your existing sources, and format it for use by Kubernetes, IAC tools, apps, and runtime. So with CloudTruth, we've introduced this concept of a configuration sync hub that allows you to easily share secrets, parameters, and environment variables across dev, ops, and security. So everyone's on the same page, you get more perfect deploys, and you can track changes across all your projects. So that's what we're working on, and I'm going to jump over to our web app and give you a brief demo. Everything I can do in the web app is accessible via a CLI, and the CLI is usually our primary interface for most folks that like to live inside of the terminal. There's four main areas of functionality that CloudTruth helps you manage your configuration across a number of different dimensions. The first dimension being all the environments that you need to provision and configure. We like to help you adopt a dry approach to configuration management, which means don't repeat yourself, and as much as possible, use common settings, and then have the ability to do quick and easy overrides that get tracked as change management across all your various deploys. So you can enumerate all your environments in CloudTruth. Typically see dev, production, staging, and child environments. CloudTruth is great for a single cloud or multi-cloud or hybrid cloud. And we have the concept of generating release tags as it relates to your configuration data, so you can bundle up all your config values, your parameters and secrets alongside of a release and keep track of that within our system as part of your GitOps workflow. The second main area of functionality is managing your config data for all your projects. So I'm going to use Terraform as an example for this demo. And the order of my hierarchy here is I have a parent project called infrastructure, which has a lot of common settings that I want to make available to child projects. And I have a secrets child project, and in Kubernetes and Terraform under secrets that can inherit these values throughout the hierarchy. I can also do overrides as needed. Projects and environments work hand in hand to help you manage these dimensions of configuration scale. The third area of functionality is our ability to give you a centralized, synchronized view of all your configuration data. My project selector has me set up looking at Terraform, which is a child of secrets, which is a child of infrastructure. If I go to the top of the tree, I can see my infrastructure values that are going to be available to my child projects. I can open up secrets, see my inherited infrastructure values, plus the values for secrets, and then go right into Terraform. So for this one screen, I can see values that I inherit from my parent, as well as the values directly in this project, which I can edit directly now I'm in the project. We're looking at this centralized view. I can see information that's being gathered from a Git integration or AWS Secret Manager, or CloudTruth itself can be your parameter and secret store if you want to use this for that. So there's two operating modes, direct parameter and secret store, or use this as an integration point to fetch data from your existing sources of truth. I can overlay an environment perspective to see what those values will be. For example, my production values for autoscale nodes is 15, but for staging is 5. So I have one place to go to see all my config values for all my projects and get all my team members on the same page. A companion view is being able to compare settings across multiple environments. I can select production and staging and look at those environments side by side for my Terraform project. And what I want to know about is just what's different. So I'm going to just look at non-secret data. And our goal here is to highlight exceptions to the rule. So in some cases, you want the same parameter value across all your environments, and you want to get notified if it's different. And in other examples, you want to make sure this parameter value is different across all environments. You wouldn't want to see the same database password on staging and production. A similar report is to look at the history of changes over time. Compare helps us figure out what's the difference between environments. Maybe you're trying to promote from a lower level to production, it's not working, it's often a configuration value. The history of changes lets me troubleshoot production worked great yesterday, doesn't work today, something might have changed, and you want to figure out what that is as quickly as possible. So I have my current values for my production environment. I can select a date range and select what's changed since that date range. So I can go back a few months, click OK, run the report. And then we're using a time series database to keep track of all your configuration values, no matter whether they're input integrations or directly stored inside of CloudTruth. This is one place to be automatic change tracking. And with the click of a button, I can show differences in just what I want to see about in terms of certain values, like this secret doesn't exist in the past. This value's changed from a previous time where it was a different value. So you have at a glance view of changes over time across all layers in your stack. So up until now, I've been talking about the idea of input integrations where we can fetch from any source, some of the capabilities of the configuration data hub. Now I'm going to talk about output integrations. And output integrations we call templating within our system. So I'm going to open a sample template. Templates can be in the format of your choice, JSON, YAML, ENV, plain text. There's an interactive editor. I can choose from a parameter and secrets values from my project or any of my parent projects I have access to. And we're using liquid templating, so templates can be very powerful. And with just a couple lines of code, for example, down here, I can iterate through all the parameters in my current project and have them be part of the template. Templates are accessible through our API or CLI, so you can drop these templates into your existing workflow and replace a lot of your homegrown tooling with this more centralized, predictable approach. We have the concept of implicit values and interpolated values. So templates can get quite sophisticated, and this starts to become a low-code, DevOps-centric app creation platform for managing sophisticated configuration workflows. Let me submit the changes here. And now I can preview a template for a given environment. Let me choose a dev environment and see what these values are. I can see my instance types, M5 large, an AMI that's going to be used. This example here is a very basic implementation of using CloudTruth to generate Terraform TF-vars files as either part of managing Terraform directly or in conjunction with TerraGrunt or Pulumi or another Terraform wrapper. I can preview against my production environment, see that the instance type is different, AMI is different. So you start to see the power of this capability where you can be very dry with your config and get the ability to have more perfect deploys to help increase velocity and reduce misconfigurations that cause unplanned downtime or security incidences. Let me take the conversation one level deeper and show you an example of what's happening at the per parameter level. So we're going to change projects to default, which has more keys and values. And I'm going to choose a specific parameter and take a deep dive into what's happening at that layer. So let's choose Redis. It's a pretty common system. A couple things to note. There's an area to keep collaborative notes across your team. This helps everyone get on the same page, reduce that reliance upon tribal knowledge in terms of understanding configuration settings. Soon we'll be offering the ability to do blast radius analysis on config values. So this will be a list of all consumers of this parameter so you can understand which systems will be affected if you're planning to make a change. And we have the ability to let you enforce rules and ranging on parameter values to avoid misconfigurations. This is where the DevOps team can set up the guardrails and let other teams make changes within those guardrails. So I can select this can be an integer, a boolean, or string, or any custom type I might want to add to get very specific. So I'm going to say this is an integer. And then additionally, I want to set some constraints, which is not to allow a value greater than 4 gigs or a value less than half a gig. This is an effort to help you avoid misconfigurations that can cause unplanned downtime. The way we help you implement a dry approach is through this tree structure here of all of our environments. So we're setting a system-wide default of 1 gigabyte for anything that's not overridden. For all dev systems, we're overriding to 2 gigs. And even down to the leaf road, you can have a further override, say to 4 gigs. For production, we're starting at 4 gigs, and then all the other sub-environments inherit that. And then staging is an example of sourcing this value from an external integration. In this case, it's going to be an AWS integration. And there's a nice editor here to set that up. So I can navigate to where I want that to go. And I'll choose S3. And I have a sample data file here. And the pointer to the file that I want to reference is this statement. The James path code is here. Click see value. It's 512. I'll save that. So now every time the API or CLI or the web app is requesting the redis.sizing.memory value for the staging environment, we're going to fetch it from S3. It could also be GitHub, AWS Secret Manager, Parameter Store, any of our input integrations. And we're going to keep the history of this value as it changes over time. This becomes your automatic change management system for all your configuration data. I can also see which templates are referencing this parameter and click into that. Here's a template for deploying a stack. And I can choose my dev environment to see what those values will be, or my production environment, again, to preview that. My Redis value is 4096, which we saw that back in the tree structure. So that's a quick preview of what we're doing at the parameter level. Other elements of the platform include a full system-wide audit log that keeps track of all the changes happening across different actions, object types, users. This can be scripted to export and upload to an upstream SIM. There's an ability to manage all your custom types. There's a full workflow system for importing your existing config or synchronizing your config against other services such as Secrets Manager or SSM. And there's a full access control for managing users, single sign-on, and permissions to different projects and environments. So that's a quick overview of CloudTruth. Thanks so much. And you create a free account at cloudtruth.com.